What I want you to do right away with this problem is make yourself a table like I did right here, where you have the probability of A, okay, oops, that was not what I meant. The probability of A right here, and the probability of not A, which is basically 1 minus the probability of A. And in the columns, the probability of B and the probability of not B. I want you to write those out, and then for each of the entries in this table, I want you to multiply those two together. Okay, and I'll let you pause the screen and you go ahead, fill in your table, and I'll pick back up and explain why we're doing this thing. All right, so the way you deal with probabilities is if they're both supposed to happen, like A and B, you figure out what the likelihood of that is by multiplying the probabilities of those two independent events together. So if I have a 50-50 chance of flipping heads with a nickel and a 50-50 chance of flipping heads with a quarter, what are the chances that they're both heads? Well, it's 0.5 times 0.5. I have a 25% chance of flipping two heads. That's intuitive because we do it all the time, but we don't often work with probabilities like weird numbers like this, but the rules work the same. So what's in here is each of these multiplied together. 0.23 times 0.75, for example, is 0.1725. 0.77 times 0.25 is 0.1925. So check your table, make sure you've got that all squared away, and let's start talking about the answers to some of these questions. My fourth question is probably the easiest one. It just got sorted that way randomly. What's the probability of both events A and B occurring? Well, you multiply probability A by probability B, and for us that's going to be 0.1725. Okay, so that would be our answer to this one, 0.1725. Some of them are a little more complicated. So let's see. Here's one. What's the probability of neither event A nor event B occurring? Well, that means not A times not B. Okay, neither one of these things is occurring. So we take probability not A times probability not B. Okay, and we get 0.1925. That would be our answer right there. The phrasing is important, so it's worth spending a little time reading the phrasing of the prompt and making sure you understand what it's talking about. Let's take the first one. First one says, what's the probability of either A or B, but not both? So what does that mean? This is probability A and not probability B. Okay, that's one possibility, but this is another one that would work. Not probability A and probability B. Either of these would be fine. So what I have to do then is take probability A times not B, that's this one, and I also have to consider probability of not A times probability of B, and then I add those things together. So calculator will be handy in this one. 0.5775 plus 0.0575. So when I add those two things together for my problem, I get this, 0.635. If you're getting the same numbers as me, that means you're following along, you're doing this right. And let's talk about that last one. I think that might be the hardest. What is the probability of at least one of the two events, A or B, occurring? Well, actually, this isn't that bad. We've already done most of the work for this one. If you take a look up here, this one said, what's the probability of neither event occurring? Okay, well that's like the exact opposite of this one. I just want at least one of them occurring. It could be both of them. It could be just A. It could be just B. So one way to do this is to add up this box and this box and this box. Basically add up every box except the case where neither event occurs. You could do that. Another perfectly good way to do it, just as good, would be to simply take the case that you don't want to consider, which is this one right here. See, we don't want that. That's the one thing we can't allow. And you simply say 1 minus that thing. Okay, and that'll give you the same exact answer, something around, I don't know, 0.8075. Okay, that's the case right there. As a parting exercise, add these things up. If you add them all up, what do you get? Does it make sense?